Okay, today we're in section 3.4 of Al Grosch's book, Developmental Math 2. We're going to talk about the slope of a line. You may or may not have heard the term slope before, but what is the slope of a line? Slope is best really to think of as just a number that measures how steep a line is. It's a ratio. We see this ratio a lot of times as a fraction, usually not as a decimal, but in some applications a decimal is good. The fraction indicates rise over run, which you can see here in this explanation. Maybe. There we go. The fraction indicates rise over run, or the change in the vertical over the change in the horizontal. So down here there's a couple of examples about how to count slope, or how to figure out what the slope line is when you're looking at the graph of a picture, the graph of a line. Okay, so if we enlarge this graph here, we can see that there's a graph of a linear equation here. The equation goes this way, and this triangle is just helping us to measure the slope. So to do this on a graph, you have to identify 2 points on the graph, and these points have been identified here by the author for you, and then you draw a triangle between those 2 points, and the one side is vertical of the triangle, the other side is horizontal. This will be the rise over the run. So if we count how high this vertical line is, or how high the triangle is, we count 1, 2, 3, 4 units high. This triangle is 4 units high. So the rise of the slope would have a 4 in the numerator, and then the run will be how long the triangle is horizontally. So 1, 2, 3, 4, also 4. So the rise over the run, the slope ratio for this triangle is 4 over 4. I'm sorry, it's not 4 over 4. It looks like the run is only 3, isn't it? 1, 2, 3. Okay, it looks like the run is only 3. So my mistake there. And also, when you look at this line, it's going downhill. So this is a negative slope because the line itself is going downhill. We're going to talk about that, I think, on the next page. So that makes this a negative 4 over 3, this slope. A negative 4 over 3. If we scroll down here, there's another slope that we can count. This line goes uphill, so this will be a positive slope. So we don't have to worry about whether the rise and the run are negative or positive, because we know this ratio should be positive at the end because the line goes uphill. So again, here's the triangle that counts rise and run. So how high is this triangle? It looks like it's 1, 2, 3 units high. So the rise is 3. And the run, how long is this triangle? It looks like 5 to me. So this would be 3 over 5 for a run. All right, these are some examples of what I was just talking about with positive and negative slope. All of these lines here go uphill. If they were graphs of your bank account, this would make you happy because your bank account is increasing as time progresses, and that's a positive slope. So all of these are positive slopes, okay? These lines all go downhill, and if these were graphs of your bank account, it would make you sad. And these are negative slopes. Sometimes I call these the happy and the sad, and that helps me remember their positive and negative slopes. So if we look down here at this example, we may need to enlarge this so that we can count this slope. It looks like there's a line here that's not drawn in between these 2 points. So you can do that if you want. But we're going to use these 2 points to count the slope, the rise and the run. And to do that, we're going to connect them with the triangle, just like the others were on the last page. If I can actually get my pen to write. There we go. There's the triangle. So the rise is here. If we count that, the height of that triangle, that is 2 units high. So slope, and we use the letter M for slope, is rise over run. That's vertical over horizontal. In this triangle, the rise is 2. And the run is the horizontal right here. The run is 3. Is this slope positive or negative? Because we can see the line going off downhill, this would make our bank account sad. This is a negative slope, so we'll assign this ratio a negative. So the slope of this line is a negative 2/3. If we scroll down to the next graph, the line is already written for us, but we're going to have to identify some points that we can connect with a triangle. It looks like you can use the intercepts. Here's the x-intercept and the y-intercept. They're really close together, but you can connect them with a triangle like this to count the rise and the run. So again, the rise is the vertical height. In this triangle, the rise is 2. The run is the horizontal length. In this triangle, the run is 1. This line goes uphill, so this slope has a positive orientation. This would make me happy if it was my bank account. So this is a positive slope. The slope is a positive 2/1. We always simplify our fraction, so this needs to be simplified. To write it in its simplest form, 2/1 is equal to 2. So this line has a slope of 2. And if you're filling in your workbook here, you're going to want to put that right up there. This line has a slope of 2. All right, what does slope mean? Slope is a rate of change, the steepness of a line. We just talked about this a couple pages ago. That's all that slope means. Here we have a word problem that involves slope. Al would like to improve his health by joining a gym. To join a gym, there is a one-time membership fee of $100 and a monthly fee of $30. Write an equation to describe the situation using y as the total cost and x as the number of months going to the gym. So how much is Al going to pay out for his gym membership? That's the question. We're going to write an equation here using x and y. So y refers to the total cost. So the equation is going to start with y, the total cost. Well, since Al is paying $30 a month, and x represents the number of months he's joining the gym for, we would have to multiply the cost per month times the number of months, or 30x. But he also has to pay the one-time membership fee. So this is not his total cost. To his monthly cost, we're going to add the one-time total cost, the one-time fee of $100. So this would be the equation, y equals 30x plus 100. This is where y represents his total payout, x represents how many months he's joining for. The next part of the question asks, what part of this situation is changing when x, or the amount of months, changes? When we look at this, the 100 is never changing. Doesn't matter how many months you join for, you're always paying this 100. It's not changing. But the 30 is being multiplied times x. So if you only join for 1 month, this part is only 30. If you join for 2 months, this will be 30 times 2, or 60. For 3 months, 30 times 3. This is the part that's changing. What part of the situation is changing when the amount of months changes? Well, this part is changing. Is the one-time membership fee or the total charge of the monthly fees? Which is it? Well, it's the monthly fees right here that are changing. So that's how we're going to answer this. The monthly fees are the part that's changing because this is the part that involves the slope. Label the variables, the change in y over the change in x. The slope is rise over run. In this situation, the slope is the number that's being multiplied times x. In this situation, the slope is 30. The run is 1 because 30 is 30 over 1. The rise is 30. For every 1 month, the monthly cost is changing by 30. And that's what this means. For every month that Al is being a member of the gym, his monthly cost is changing by 30. Okay, sometimes we have to find the slope when we don't have a graph. And in those situations, we're usually giving 2 points that we can calculate slope from if we know 2 points. This is called the slope formula. We can use it when we don't have a graph to calculate the slope when we know 2 points that are on the graph. We call it the slope formula. This is something that if you are being tested, you're going to want to memorize this formula here. The slope formula says m, which stands for slope, m equals y2 minus y1 over x2 minus x1. Notice those little numbers, the 2 and the 1, they are not exponents. They're what we call subscripts. And they're just differentiating. When you use subscripts like this, there are 2 different y values. They're just giving names to 2 y values. This is the first y is y1. The second y is y2. The first x is x1. The second x is x2. And to use this formula, here's an example. Find the slope using the points 6, -3, and 4, 3. When you have 2 points, you have 2 x's and 2 y's, and you can fit them into the formula. I usually do this by labeling the points, just like your author has shown here. I usually label them as x1, y1, x2, y2. This is an x. And then when I take those points, I can fit them into the formula here. So that's what the author is showing you here in step 2. Substitute the values into the slope formula. Well, y2 minus y1 is 3 minus -3. So that's why we have the 2 minuses here, because the first minus comes from the subtraction in the formula. The second negative was on the coordinate of -3. So when I line those up as y2 minus y1, I get 3 minus -3, which is actually 3 plus 3, which makes 6. And then in the denominator, x2 minus x1. x2 is 4, x1 is 6, so 4 minus 6, -2. And always simplifying. 6 divided by -2 makes -3. So the slope of the line that has these 2 points in it will come out to be -3. And a way to check that would be to make a graph and actually graph these 2 points on it. Okay, they would be going downhill. And then draw the triangle and count the rise and the run. And you could do it that way, but you're going to need to know this slope formula. All right, let's do example 2. Let's see. I'm going to write next to the author's notations here. So we have find the slope given these 2 points. So we have x1, y1, and x2, y2. And we're going to fit them into the formula, which is given for us to practice right here. y2 minus y1 on the top is going to be 5 minus 6. So we're going to write that on the top. 5 minus 6. x2 minus x1 in the denominator is going to be 5 minus 3. So we'll do that in the denominator. 5, let's see, let's get a color here. 5 minus 3. Well, when we simplify 5 minus 6 in the numerator, we get -1. When we simplify 5 minus 3 in the denominator, we get 2. So the slope, this simplifies to -1/2. The slope of the line that contains these 2 points will be -1/2. Okay, so we've got a couple more examples here. We have, given the points -2, -2, and -12, -8, find the slope. So we're going to mark these as x1, y1, x2, y2. And we're going to fit them into the formula here. So the numerator will be y2 minus y1. So -8 minus -2. -8 minus -2. And be careful. You need to make sure you always get the subtraction that's in the formula and any minus signs that are actually on the coordinates. And sometimes they make this double negative like this. In the denominator, we're going to have x2 minus x1. So -12 minus -2. -12 minus -2. And then we're going to simplify. All right, don't forget, these two negatives together are actually going to cancel to make a positive. So in the numerator, we end up with -8 plus 2, which is -6. In the denominator, we end up with -12 plus 2, which is -10. When we simplify that, the two negatives in the numerator and the denominator will cancel each other. Negative divided by negative makes positive, and we're going to simplify this fraction by reducing it. They're both divisible by 2, so we get a slope of 3/5. All right, let's do this last example. Given the points 8, -4, and 8, -3, find the slope. So again, label them as x1, y1, x2, y2, and fit them into the formula. All right, y2 minus y1 is going to give you -3 minus -4. So that's going to be in the numerator, -3 minus -4. In the denominator, x2 minus x1 is going to give you 8 minus 8. All right, so in the numerator, when we simplify, these two negatives cancel to make a positive, so -3 plus 4 equals 1. In the denominator, 8 minus 8 is 0. So this is a special fraction with 0 in the denominator. If you remember your fraction review, any fraction that has 0 in the denominator is what we call undefined. So this slope is undefined. Turns out, we're going to talk about this a little bit in a couple of pages, that an undefined slope indicates a vertical line. So this is a vertical line. All right, so on the next page, we're going to talk about horizontal and vertical lines since it just came up with slope. Horizontal and vertical lines are special when we talk about slope in that they actually have special slopes, and their equations look kind of special too. When we look at these horizontal lines, and you can see it's right there, the horizontal line, the equation says y equals 2. There's no x term in the equation. With an equation that says y equals some constant, the line comes out to always be horizontal, because what it's saying is no matter what the x coordinate is, the y coordinate will always be 2. And when you plug in 2 points from a horizontal line into the slope formula, you end up with something that looks like this. The slope is always 0 for a horizontal line. And the equation always says y equals some constant. And you can tell what the constant is because when you look at this horizontal line, it's crossing the y-axis where y equals 2, and this is a horizontal line where all the y coordinates will be 2. It's crossing the y-axis at y equals 2. If you look at this one next to it, the equation is y equals -6. It's crossing the y-axis where y is -6, and again, it's a horizontal line. The form of the equation is y equals some constant. It makes a horizontal line, and all horizontal lines have a slope equal to 0, and the little letter m stands for slope. The slope is 0. So we have some practices for horizontal lines down here. I'm going to enlarge a little bit so we can see the graph. This first one says practice graph y equals -4. So again, this is the form of the line. The equation is y equals a constant, and this always makes a horizontal line where y is -4. So we're going to go down the y-axis where y is -4, and we're going to make a horizontal line here. 1, 2, 3, 4. We'll make a horizontal line at y equals 4, just like that. This is the graph of y equals -4. The equation for the graph looks like this. The slope, indicated by little letter m, is 0. When we graph y equals 3, the equation again says y equals some constant. We will go to 3 on the y-axis, and we will make a horizontal line. So this is the graph of y equals 3. The equation is y equals 3. The slope, indicated by m, is 0. On the third one, we're going to practice another y equals 0. This is a horizontal line where y is 0, and that equation makes a line right on the x-axis. This is the equation for the x-axis. So you can make a line right along the x-axis, and the slope is also 0. On the next page, we're going to talk about vertical lines. These lines have a different kind of equation. It's very similar. This time it just says x equals a constant. This is the equation for x equals 5, and you can see this time the line is vertical, where along the x-axis is the point 5. All of these x coordinates are 5. There are also y coordinates, but it doesn't matter what they are because x will always be 5. When you put in points from a vertical line into the slope formula, it doesn't come out to be 0 because it turns out that the 0 ends up in the denominator of the fraction, which makes this slope undefined. There is a difference between slope 0 and slope undefined. Vertical lines have a slope that is undefined. Horizontal lines have a slope that is 0. So this is the graph of the equation x equals 5. Over here, we have the equation x equals -7. Go to -7 on the x-axis, a vertical line. It has a slope undefined. Vertical lines have a slope undefined. So again, we have a few practices down here below. We're going to practice graphing x equals -2. To graph x equals -2, we're going to go to -2 on the x-axis, and this line is a vertical line where x is -2. So we're going to make a vertical line graph of x equals -2. We're also going to write in the slope is undefined. My writing is really sloppy with this pen here. Sorry about that. On the next graph, we're going to practice graphing x equals 4. So we're going to go to 4 on the x-axis, and we're going to make a vertical line. This is the graph of x equals 4, and the slope is undefined. On the third one, we're going to practice graphing x equals 0. So where is x 0? Well, again, right here at the origin, the graph of x equals 0 is the y-axis. So we can go over it with our pen to indicate that we know this is right here on the y-axis, and we also know the slope is undefined.